Hello, in this video, I'm going to walk you through the different calculations for the average velocity table. So the first thing we want to do is calculate our time, elapsed time. We're looking to study the motion for 120 seconds. So we start out with 0 seconds. And what we want is for this one to be one more. We want it to be equal to one more than the one above it. So we click in that cell, type in equals 1 plus the cell above it. We hit enter, come back to this cell, arrow over the blue square, and we fill down. The next thing is we want the instantaneous velocity. And the instantaneous velocity formula is v equals ap plus v0. Well, in this case, the acceleration is caused by gravity, so that's minus 10. The initial velocity, since it's dropped, is 0. So the instantaneous velocity is simply negative 10t. So equals minus 10 times t. And we fill that down. The next thing is we want the cumulative average velocity. So at every instant in time, this time or this time or this time, what is the average velocity of the entire journey? Well, that formula, v bar, is equal to final velocity plus the initial velocity divided by 2. Now this formula we can use because the acceleration is constant. It's a constant minus 10. So we can use that formula. So we want this cell to be equal to the quantity final plus initial divided by 2. To check ourselves when we do this calculation, we fill it down, we should ask ourselves, are the values coming out of it reasonable? So when we look at this value here, minus 20 and 0, the average should be minus 10, but it's not. And so when I look at the formula, it's not averaging the initial velocity, it's averaging the most recent velocity. So what I want it to do, the formula, is to lock in on this cell here where there's a 0, B6. And the lock in is a $sign B, $6. We want it to always start in column B, always row 6. And now when we fill that down, we get minus 10, minus 20 as it should be. Now the next one, the displacement, is from this formula, the average velocity equals delta x divided by delta t. Because we want the delta x then, delta x, when we solve for delta x, will be equal to the average velocity multiplied by the change in time. And since the beginning interval of time is the very beginning 0, delta t equals t. So this equals this times time. So minus 20 times 4 is minus 80. That's correct. Now the next column, the position, is related to the displacement. Because the displacement, delta x, is defined as final position minus the initial position, x minus xo. So x then is equal to displacement plus the initial position. All we have to do is add in the initial position. So the position is equal to the change in position plus the initial position, which is located up here. But we want it to always refer to that box. So that's what we need, a $B, $4. Always column B, row 4. Now, of course, this is empty, but this number should be 0 if we set the starting location as 0. And we can then see that delta x and x are equal to each other. So I put these formulas down here so we can see them. To get to 120 rows, it's a simple matter for me to highlight these rows down to about 126 or so, and insert rows above. And we can see this here will go to about 126. Let's fill these formulas down. And lo and behold, we get 120, and there are formulas that they relate to